Okay, let's take a look at an application of derivatives in chemistry. So the mass in grams of a compound being formed during a chemical reaction is modeled by the function m of t is equal to 6.3 t over t plus 2.2, where t is the time after the start of the reaction in seconds. Determine the rate of change of the mass after 6 seconds. Okay, so we have mass in grams per unit time, right, as a function of time. Let's figure out the first derivative, or the rate of change of mass, m prime of t, which is the rate of change of mass per unit time dt. And then I'm going to do the derivatives. I'm going to be utilizing quotient rule for this. So this is, I'm going to do the derivative of the numerator with respect to dt, 6.3t times t plus 2.2. Okay, and then I'm going to subtract this by the derivative of the denominator, t plus 2.2 times 6.3t, and then I'm going to divide all of this by the denominator squared, so t plus 2.2 squared. Okay, so the derivative of 6.3t is basically 6.3 times t plus 2.2 minus the derivative of t plus 2.2, which is 1 times 6.3t. Okay, and if I simplify the numerator first, so I'm just looking at the numerator right now. Okay, so I'm just going to kind of simplify the numerator and then kind of add on the denominator. So you have 6.3t plus 2.2 times 6.3, which is 13.86 minus 6.3t. You can see that the 6.3t and this negative 6.3t cancel out, and you're left with 13.86 over t plus 2.2 squared. Okay, so this is basically m prime of t, right? So it's the rate of change of the mass. Now we want to figure out the rate of change of the mass after 6 seconds. So we're doing m prime of 6, which is 13.86 divided by 6 plus 2.2 squared, and that's going to give you 0.206. Okay, so this is the rate of change of the mass after the 6 second mark. It's 0.206 grams.